Hello students, we'll continue our class on antihistamines, and in this video we'll be seeing about the mechanism of action of antihistamines and the important structural features of antihistamines in general. Antihistaminic agents are reversible, competetive, H1 receptor antagonist. That is, they inhibits the interaction of histamine mainly at the H1 receptors. They don't have much action on the H2 receptors. And coming to H1 receptors are G-protein coupled receptors. G-protein coupled receptors contains 487 amino acids and 7 transmembrane loop. We have seen the structure of histamine. Histamine contains 3 nitrogen atoms, 1 primary amino group and 2 nitrogen atom in the aromatic ring. And these 3 nitrogen atom binds with the G-protein coupled receptors at 3 points. These G-protein coupled receptors have constitutive receptor G-protein signaling activity. That means they initiates or activate certain biochemical reactions in the body even in the absence of histamine. Once the signaling system is activated, it releases certain chemical compounds like ionositol 1,4,5-triphosphate, diazyl glycerol, cyclic AMP, nitric oxide, etc. and that can mediate various histamine-related responses. Now, this H1 receptors can exist in 2 conformations. One is the active form of the H1 receptor and the other one is the inactive form of the H1 receptors. And these 2 active and the inactive form of the receptors exist in equilibrium with each other. Now, what will happen when histamine is released from the mast cells? So, the released histamine can combine either with the active form of the receptor or the inactive form of the receptors. The histamine combines with the active form of the receptor and shifts the equilibrium towards the active form of the receptors. We'll see how antihistamines act. Antihistamines can be considered as an inverse agonist. That is, the antihistamine combines with and stabilizes the inactive form of the H1 receptor. And as a result of that, it shifts the equilibrium towards the inactive form. So, more amount of the H1 receptors will be in the inactive form and the cellular and the biochemical reactions will not be mediated. So that's all about the mechanism of action of antihistamines. Now we'll see the chemistry of antihistaminic agents. First, we'll see the structural features of antihistamines. We have learned the structure of histamines, and in that we have seen that it contains a primary nitrogen atom and an aromatic imidazole ring connected by a ethyl chain. And so similarly, antihistamines also have a similar structural features. Instead of a primary amino group, antihistamines have a tertiary nitrogen atom. And then the aromatic system, instead of a simple aromatic system, antihistamines have a larger or a complicated or you can say a bigger aromatic system. And this aromatic system is connected to the tertiary nitrogen atom by means of a ethyl chain or a 2 or 3 carbon chain. This is the general structure of antihistamines. You can see a ethyl chain CH2CH2 that connects the tertiary nitrogen atom, tertiary aliphatic nitrogen atom with a aromatic ring system, and that it is connected through an atom X. X can be either carbon, oxygen or nitrogen atom. And so this antihistamines can be considered as a substituted ethyl amine derivative with a tertiary nitrogen atom and 2 aromatic ring substituents. And depending upon the X, you can have different types of or different classes of compounds. So now we'll see the different classes of antihistamines that are possible depending upon the different types of the atom X. It can be either carbon, oxygen or nitrogen. So if the X is a nitrogen, then you have two nitrogen atoms, then the resulting compound can be considered as a ethylene diamine derivatives. Now next, if the X is a carbon atom, saturated sp3 carbon atom, then you will have CH2, CH2, CH2. That is a propyl chain that links the nitrogen atom with the aromatic ring system. So you have a propyl amine derivative, or you can say it has a alkyl amine derivatives. And finally, if the X is an oxygen atom, then you will get OCH2CH2N. Then you can consider the compound as an ethanol amine derivative, amino alkyl ether derivative. So depending upon the nature of X, you can have ethylene diamine derivative, or a propyl amine derivative, or an amino alkyl ether, or an ethanol amine derivative. Next structural feature is the tertiary amine. The tertiary amine or tertiary nitrogen is essential for maximal antihistaminic activity, and the substitution is usually dimethyl amino. Smaller alkyl groups are attached to the nitrogen atom. So nitrogen can also be a part of heterocyclic ring systems like piperidine or a piperazine. Okay, then amino moiety, as you know that nitrogen is a basic in nature. So the amino moiety is basic with a pKa value ranging from 8.5 to 10. And the protonated form of this nitrogen atom, primary nitrogen atom, is essential for binding with the receptors, and hence it is necessary for the affinity and binding with the receptor, and it is also important for the development of stable solid dosage forms. Ethyl side chain CH2CH2N. This ethyl side chain, or the two carbon side chain, connects the center of aromatic ring and the aliphatic nitrogen atom. The distance between them is usually 5 to 6 angstrom, same as that in the case of histamine. Generally, the extension or branching of this carbon chain results in a less active compound. Next structural feature is the aromatic ring system or the aryl ring system, and this diaryl substitution is present both in the first and the second generation antihistamines, and they are required for the H1 receptor affinity. And these two aryl groups must be in a non-coplanar conformation relative to each other, that is, they must be in two different planes. And the first aryl group is usually a phenyl ring or a substituted phenyl ring like benzyl, or a heteroaryl ring like 2-pyridyl. And the second aromatic ring is usually a phenyl or an aryl methyl group. And in some cases, the two aromatic rings may be fused or bridged, as in tricyclic derivatives like phenothiazine derivatives. So that's all about antihistamines, structural features of antihistamines. In the next video, we'll see about the classification of antihistamines, first generation or the older generation, and the second generation or the newer generation antihistamines, mast cell stabilizers like cromolyn sodium. So till then, bye. Thank you.